Unit 1, Lesson 4, Angles. Your objectives for this lesson are to define vocabulary related to angles. There is a lot of vocabulary in this lesson. You also need to make some formal constructions, and we'll be doing that in class. First, this is a review from Lesson 1. So an angle, as you can see on the side here, is two rays with the same initial point. Okay, so each side here then is a ray, so the sides are the rays, which makes this, the vertex, the initial point. So when we are talking about angles, we're not going to say the initial point, we're going to say the vertex. Okay. The question here is, how do we measure angles? And again, this is review, so you measure angles with degrees. So degrees are your unit. And 1 degree is 1/360th of a circle. So using this knowledge, you can infer that there are 360 degrees in a circle. You've probably heard that before also. Angles are classified based on their size. So this is one way that you can classify angles. You see, this is an acute angle. And an acute angle is any angle where the degree is greater than 0 but less than 90 degrees. Okay, this is theta. So you spell that T-H-E-T-A, theta. And that just stands for whatever the angle measure is. So theta is whatever the angle measure is. When it is between 0 and 90, you have an acute angle. A right angle is when theta is exactly equal to 90 degrees. So no more, no less, exactly 90. And that you'll see often a little box there. So that box will stand for a right angle. An obtuse angle, theta is between 90 degrees and 180 degrees. So this is an obtuse angle. And then a straight angle, you can see here we have a straight line. That is when theta is equal to exactly 180 degrees. So this is the angle, and that's exactly 180 degrees. So these are the different types of angles that we will be dealing with in this class. Okay, the protractor postulate. This here is a protractor. We've used them in class now before. And protractors are used to measure angles, just like a ruler is used to measure length. So the protractor postulate tells you how to use the protractor, and I'll demonstrate that for you now. We'll practice this more in class also. So you want to take this part of the protractor. There is sometimes a hole there on a physical protractor, and you want to put that on the vertex of the angle. And I like to rotate this so that the straight line here at the bottom is either at 0 or 180 degrees, lines up with one of the rays, one of the sides of your angle. And then you're going to look up here and get a reading. So I can see this angle is about 115 degrees. So this is halfway between 110 and 120, so that's 115 degrees. You can use the outside or the inside to measure, but be careful. I used the inside here because this is 0 and this is 115. So I could say OB is 0 minus OA is located at 115. So the absolute value of that, I have the absolute value of negative 115, which is 115 degrees. Okay. That was using the inside. Using the outside numbers, I'll do this one in blue. So OB is then located at 180 minus OA is halfway between 60 and 70, so 65 absolute value. And I get the absolute value of 115, which is 115 degrees. So either way, I'm getting 115 degrees, but you have to do a consistent reading, so do both rays, measure them on the outside, or both measure on the inside. Okay, the angle addition postulate says that if you have a large angle, such as RST, angle RST, that is made up of two smaller angles, such as angle RSP and angle PST, you can find the measure of the big angle by adding these two little ones together. So if I know that this little one is 30 degrees and this one is 20 degrees, then I can say 30 degrees plus 20 degrees equals 50 degrees. You can also move the opposite way to find the measure of a smaller one if you have a big one and the other small one. Okay, here are some angle relationships. So adjacent angles are two angles with a common vertex and side, but no common interior points. So no common interior points is important. Right here, angle 1 and 2, you can see they have the same vertex. They share this side, so angle 1 and angle 2, but they don't overlap, okay? Angle 2 and angle 3 are also adjacent angles. 1 and 3, so angle 1 and 3, are not adjacent because you see they share a vertex, but they don't share a common side. Over here, angle ADB is adjacent to angle BDC, so ADB, BDC, but not, so ADB is not adjacent to angle ADC. So it is not adjacent to this larger angle because it is inside of it. So you don't want one inside of the other. If you have that situation, then they are not adjacent. They're overlapping. Vertical angles are congruent. So vertical angles look across from each other. So here and here, these are vertical angles. They are formed by intersecting lines. Formed by intersecting lines. This is an important angle relationship. I like to remember it because when they're looking across from each other like this, you have a V and a V. And oh, that's a bad V. V is for vertical. V is for vertical. Okay. 2 and 4 are also vertical angles, so these two are vertical. Okay. Complementary angles add up to 90 degrees. So here I have a 70-degree angle and a 20-degree angle. And if I take these over here, this is a 90-degree angle. It's our right angle. And they fill that perfectly. So I can rearrange them into a 90-degree angle. Supplementary angles add up to 180 degrees. So again, I can take these two here and they fill that straight line. So they add up to 180 degrees. Complementary and supplementary angles do not need to be adjacent to each other. So these are not necessarily adjacent, but they could be. Okay, the way that I keep complementary and supplementary straight, C comes before S in the alphabet, 90 comes before 180 when you're counting. Okay, example 1. Identify at least one pair of each of these different types of angles. Okay, so first, this is our very complicated diagram over here. I want adjacent angles. Remember, adjacent angles are just two angles that are next to each other. There are a bunch of pairs of adjacent angles on here, but I see angle 1 and angle 2, and they do have a common vertex right here, and they share this line here, that side wall. They don't overlap, so I'm just going to put down angle 1 and angle 2. Okay. Vertical angles. Remember, vertical V. So where do I see some V's? Some intersecting lines. I'm going to say angle 1 and angle 6 are vertical angles. So they're looking across from each other. Those are my vertical angles. Okay. Notice that I use some arcs here to mark these red arcs. I can do that here because remember, vertical angles are congruent, and that arc means that the angles are congruent. Okay, complementary angles. So this is, they add up to 90 degrees. So let's look around. I need two of them. Okay, well, since this is 90 degrees right here, and this is a straight line, that means that this whole thing must be 180. Okay, 180 minus 90 is 90. So 9 plus 10 plus 11 is 180. Minus 11 is 90. So these two are going to be complementary. So angle 9 and angle 10 add up to 90. Supplementary angles, they add up to 180. So I actually identified one pair right here, or not, I'm sorry, that's not a pair, that's three of them. I guess the three angles are supplementary, but I want just two angles. So let's see, two angles that form a straight line. And I'm going to use 7 and 8 right here. So angle 7 and angle 8. You can see some other pairs, 3 and 4, 3 and 7, 4 and 8. There's bunches of pairs of all these. I only just put down one. Example 2, use angle relationships to find the missing measure. And this is the same diagram as last time. So angle 4 in part A is 90 degrees. We can see that based on this box here also. So we want to find angle 3, 7, and 8. Well, 3 and 4 are on a straight line, okay, which means that they add up to 180. So the measure of angle 3 is 180 minus 90, so that's 90 degrees. Four and 7 are vertical angles. You can see them looking across from each other. So that means that the measure of angle 4 is equal to the measure of angle 7. So this must also be 90 degrees. Finally, 3 we determined was 90 degrees. 3 and 8 are vertical angles. So they're equal, which means that the measure of angle 8 is also 90 degrees. The measure of angle 1 is 45 degrees. So 45 degrees. Find 2, 5, and 6. Well, I'm going to do 6 first because I think that's the easiest. 1 and 6 are vertical angles. They will be the same. So measure of angle 6, 45 degrees. Okay. Now, angle 2 and angle 1 are supplementary. So we know that 180 equals angle 1, 45, plus angle 2. So this is the measure of angle 1, measure angle 2. Okay. Subtract 45 from both sides. And our angle is 135 degrees. So angle 2 is 135 degrees. Then, using vertical angles, we can determine that 5 is the same as 2, so this is also 135 degrees. An angle bisector is a ray that divides an angle into two adjacent angles that are congruent. So here, DB is the angle bisector. And you can see those two red arcs on our diagram showing that angle ADB is congruent to angle BDC. We'll go over how to construct an angle bisector during class. Example 3, ray BT bisects angle ABC. Find the value of x. So you see that BT is the angle bisector. That means that these two angles are congruent. Since they are congruent, set their measures equal to each other. And then we're just going to solve this equation. So subtract 3x from both sides. We get 13 equals 2x minus 7. Add 7 to both sides, trying to get the x by itself. So 20 equals 2x. Divide by 2. And x equals 10. So that is our answer. If you wanted to check that, you could go back and plug x in here and see if you get the same angle measure. Part B, again, ray BT is the angle bisector, so we are going to set these parts equal to each other. So subtract 5x from both sides. Cancels. We have 7x minus 7 equals 28. Add 7. X is equal to 35. Divide both sides by 7. And we get x equals 5. Okay, so that is it for lesson 4. We'll go over some more constructions during class time.